Good day everyone, I am Mikey B. Dumalaon, a second year BS Ed Science student. And for today's video, I will be sharing you about the behavior of gases and the laws of gases. But we will be focusing more to the Boyle's law. On the other hand, before we start this video, I will present to you the learning outcomes that this presentation aims after you watch this video. At the end of this lesson, the student will be able to first differentiate the distinctness between Boyle's law. Second is investigate the relationship between volume and pressure at a constant temperature of gas. Third and lastly, appreciate how important this applies to our everyday life. But before we proceed to the discussion, let's play a fun game first. I will be showing you pictures and you will guess what kind of gas behavior it is. If you know the answer, comment below your answer. Are you ready? Let's start. So first is very good everyone, that is a solid. Second is, yes, excellent, it is indeed a liquid. And the last one is, excellent, it is indeed gas, a behavior of gas molecule. So that's all. Thank you everyone for participating. So what we did earlier was just a recall of our new topic or lesson, which is the behavior of gases. So you have learned in grade 8 that like other solids and liquid, gases are also made up of molecules that behave differently. Most of the properties of gases can be attributed to the random and scattered arrangement of its molecules. It has a very weak intermolecular force of attraction. And wherein in grade 9, you have learned that chemical bonding and its various types. You have also learned how chemical bonding occur and how particles rearrange to form new substances. And now, in grade 10, you will learn that the rearrangement of particles happened when substances undergo chemical reaction. You will get to know how law of conservation of mass applies to chemical reaction by analyzing masses and number of atoms of substances before and after a chemical reaction. Also in grade 10 chemistry, you will investigate how gases behave in different conditions based on knowledge of the motion and distance between gas particles. Before we start the discussion about Boyle's law, the gases are described in terms of 4 properties. First is pressure. The unit of measurement used are atm, mmHg, torr, pascal. Next is volume. The unit of measurement used are liter, millimeter. So the third one is temperature, and the units of measurement used are Celsius, Kelvin. So Kelvin is required in calculation. So if the given problem is Celsius, we need first to solve the Kelvin. So for example, 30 Celsius was given. What we're going to do is we're going to add 30 Celsius to 273 Kelvin. So the equal is 300T. That is the Kelvin that you will use. And lastly is the amount or N. And the unit of measurement used are grams, moles. And this is required in calculation. So For today's discussion, like what I said earlier, I am going to discuss the Boyle's law. So, the relationship between the volume and pressure of gases at constant temperature was first stated by Robert Boyle during the 16th century. He performed an experiment wherein heat trap affects the amount of air in the G-tube. He changed the pressure and controlled the temperature, and then he observed its effect to the volume of the air inside the G-tube. He found out that as pressure increases, the volume decreases. So, class, take note of this, that about Boyle's law, that the volume is inversely proportional to pressure at constant temperature. Meaning, if the volume increases, the pressure decreases at constant temperature of gas, and vice versa. So, the formula of Boyle's law is B1 times P1 equals B2 times P2. B1 is the initial volume, while B2 is the final volume. P1 is the initial pressure, and P2 is the final pressure. Where B is volume, P is pressure, T is temperature, and N is the amount of gas. Now, let's solve this problem. The inflated balloon that's left from the hand of spring has a volume of 0.50 liter at sea level 1.0 atm, and it reached a height of approximately 8 km where the atmospheric pressure is approximately 0.33 atm. Assuming that the temperature is constant, compute for the final volume of the balloon. In analyzing the problem, it is important to categorize the initial and final condition of the variables. So in here, the initial conditions are B1 is equal to 0.50 and P1 is equal to 1.0 atm, while the final condition is P2 is equal to 0.33 atm, and we need to find the B2. By applying Boyle's law, can you predict what will happen to the final volume? That's right, the volume will increase. So let's compute for the numerical value of the final volume by substituting the given values to this equation. So B1 times P2 equals B2 times P2. So what we're going to substitute is B2 is equal to B1 times P1 divided by P2. So B2 equals 0.50 liter times 1.0 atm divided by 0.33 atm is equal to 1.0 liter. So, bakit naging L na yung unit doon? What we do was we cancel the 2 atm. So, did you notice that the increase in pressure and how it affects the final volume? Yes, the pressure decreased by 1/3. That is why the volume is increased by 3 volts. So let's try what you have learned in my discussion. So let us solve this problem. So the problem is a fixed amount of gas occupies a syringe with a volume of 5 liter. The pressure at 30 Celsius is 1.0 atm. What will be the new pressure if the volume is 4 liter at the same temperature? pause your video for a minute and answer this problem. After that, continue watching this video and see if you get the correct answer.
A few minutes later.
So, okay. Now, let us solve the given problem. First is we need to analyze the problem. What we're going to solve is the final pressure. And now, let's categorize the given. So, for the initial, P1 is equal to 1.0 atm and the initial volume is 5 liter and the final volume is 4 liter. Now, we have the given. Let's solve the P2. So, B1 times P1 divide B2. So, 5 liter times 1.0 atm divided by 4 liter. It is equal to 1.25 atm. So, well done everyone. And that would be end of my video lesson. Thank you for watching.